Hello, all our amazing students. This is Mrs. Lizette Roman, and I am here educating you with love. Today, we're going to be going over Go Math Lesson 7 in Chapter 10. This is all sixth grade curriculum. So, what are our objectives today? Our first objective is the content objective. That means, what are we going to even be learning? Well, at the end of this lesson, you should be able to say, I can find the area of composite figures. Now, how are you going to demonstrate that you've learned it? This is where language objective comes in. I can carefully listen to the definition of a composite figure and then tell how to find its area. Now, what is a composite figure? Well, a figure is really a fancy word for shape, and that can be divided into more than one of the basic figures. And if you can do that, then it is said to be a composite figure or shape. So, for example, we have this shape right here. It can be divided into two shapes. You see, right here I have a rectangle, and right here I have a triangle. If I put those two shapes together, I've actually created a composite figure. Remember, figure is just a fancy word for shape. And remember, in Spanish, shape is figura, and those are cognates, figure and figura. So that's how I remember that figure just means shape. Here's some more examples of composite figures. Can you identify the shapes within the shape? So if I look at this shape, do you see any other shapes inside that you could break it up into? I do. How about this little house? They broke it up for you already. I see a square here, a triangle, a big triangle, and a rectangle. How about this shape? Just take a look. Can you split it up into more than one shape? Are there shapes within this composite figure? Well, here are the answers. I see, if I draw a red line right here, I see that there's two rectangles, 1 and 2. So this composite figure is made up of two rectangles. How about this house? We saw already, we mentioned that's made up of many shapes, including triangles, squares, and rectangles. Last shape. Well, if I draw a red line here and another red line here, I actually will notice that there's two triangles and one square in the middle. Some of you might view it a different way. What if I would have not drawn these red lines? I would have just drawn one big line across. That would have been two trapezoids, right? Well, there's so many ways to view this. Either way, you'll be able to figure out the entire area of that composite shape. How are we going to do it? These are the steps to finding the area of a composite figure. The first thing I do is I identify all the shapes within the composite figure. That's what we just practiced. Then I list them in a chart. Then I'm going to find the area of each shape using the appropriate formula. And last but not least, I'm going to add up all the areas to find the area of the whole entire composite figure. Let's try it. So here we have this composite figure, this composite shape made up of many different shapes. It's made up of a triangle, of a square, and then we see this shape. That's confusing to some of us sometimes, but this is called a trapezoid. It's got one base, two bases, and then you see that we have these diagonal lines here. That's called the trapezoid. So here we go. First thing I said that you have to do is identify the shapes. We just did that. We have a triangle, a square, and a trapezoid. The next thing I said you had to do was to write down the correct formula to find the area of each shape. So we know the area of a triangle. To find it, we have to use A for area equals half the base times the height. So I wrote that down. If you're not sure, go back to your old PowerPoints or your old videos. And then the square. Squares is area equals base times height, or it might be known as area equals length times width, or you might have heard area equals the side squared, okay? Trapezoid, area equals a half, parentheses, base 1 plus base 2 times height. Okay, that's the formula to find the area of a trapezoid. So let's just apply all this information because I have to find the area. I already told you the area here because I've done my calculations, but let's go over how I got that number. So for the triangle, here's my triangle. I have to find half the base. So here's my base, 16, times the height. Where's the height? I only see 20. Where'd they get 12 from? I don't see here. Well, I don't have a number here, but if you look across the way, the congruent line is 12 centimeters. So I can assume that this is also 12 centimeters. So I'm going to write 12 here. Now I can start my math. Half 16 is 8. They didn't write it down, but it's 8. 8 times 12 is 96. So I know that 96 centimeters squared, because I'm talking about area, is the area of the triangle. Boom. Done with that. Check. Okay, I'm done with the triangle. Now let's go to the square. Well, the square have base times height or one side squared. So that's this 12, only the 12 for the base of this square times the height of it. Okay, so, or length times width. All right, so 12 times 12 comes out to 144 centimeters, okay? Or 12 squared, 12 times 12 is 144. Let's move on to the trapezoid. This is a more complicated one, but you got this. So a trapezoid, this is a shape up here. Area equals a half base 1 plus base 2. So my base 1 up here, 9 centimeters. So that's where they got the 9 from. Base 2, they don't give you a number, but look across the way, the congruent line, this line is the same length as this line, is 12 centimeters. So I can assume that this is 12. So 9 plus 12 is going to come out to 21. I added up first because it's in parentheses. Okay, they wanted you also multiply that times the height. The height is from the top to the base. The height is 6 centimeters, so we put a 6 here. Let's continue on. Half times base 1 plus base 2 times height. We add these up because in parentheses first. That's 21. Now, half of 21. I don't know. That's an odd number. It's going to be really, really weird to have to figure out the half of that. Let's try to do something else that might be easier for us that I like to do. What's the half of 6? You can jump over here to find out the half of 6. Half of 6 would be 3. And then I can do 3 times 21. Well, that's a lot easier because 3 times 1 is 3 and 3 times 2 is 6. So that's how I do it in my mind. But we're not done. We figured out the area of each one of these shapes. You see, we have it all written down here. Now I have to add all these areas up to find out the total amount of space or area inside of that composite number. Total comes out to 303 when I add them all up and I line them up vertically. My ones with my ones, my tens with my tens, and my hundreds with whatever, if there were more hundreds, comes out to 303 centimeters squared. Don't forget to put that little squared there, okay? Moving on. Example number 2. This looks like a little bit of an entryway to a house. We have a triangle, a rectangle, and another rectangle. So the triangle, I'm going to identify my shapes. I just did actually triangle, 2 rectangles. There they are. With the triangle, I have to find what's the formula. This is my formula to find the area of a triangle. And I have to do my calculations to find the area of this shape. So half times 3 times 8. 3 is my base. 8 is my height because it tells me right here. From here to here would be 8. 8 feet. So now, half of 3. I don't know half of 3. I can do this many ways. I can do then 3 times 8. And 3 times 8 is 24. And then get the half of 24 would be 12. I also could have done half of 8 is 4. And 4 times 3 would be 12. Okay, so we got the area of a triangle. Moving on, the area of a rectangle. Again, to get the area of a rectangle, you could do length times width or base times height. Here is my base times the height. I could do 5 times 10. This would be called the length. This would be called the width. It's up to you. It's interchangeable because we're talking about multiplication here. So 5 times 10 comes out to 50. So the area of this rectangle is 50 feet squared. So it happens that this rectangle is the same size, so also 50 feet squared. Again, you add up all of your areas together. When you add it all up, you're going to come out to 112 feet squared. Just a little tip for those of you that are advanced in math, I also could have done something else. I could have just done 50 times 2, because I have 2 of them, to get 100, and then add the 12, and that would have come out to 112. That's just a different way of looking at it. Example number 3. Now they're trying to hurt us. I can't follow all the steps I followed before. This is a little different. My directions are different. It says find the area of the shaded region. So here is my rectangle. I know how to find the area of a whole rectangle, but it says only the part that's shaded. Oh no, that's not going to work. What I used to do, length times width. That doesn't work because it would include this space. How am I going to remove this amount from my space? Well, we have to find the area of the whole entire thing. Once I do that, I got to find the area just of this little space and then subtract and take out or cut out this space. When you're cutting something out, you're taking it away, and that's subtraction. So let's do 1 times 6 length times width. Okay, this is 1. Oh, I see. They're trying to trick you. I'm sorry, I didn't notice something. It says 1 foot. 1 foot is what in inches, because these are inches. We have to have them all the same units, so that would be 12. So 12 inches. 12 times 6, that's the length times the width. 12 times 6 comes up to 72 inches. So the whole entire space would have been 72 inches squared. But I got to take this piece out. So what's the area of this little white piece? We have to do, and it's a square because 3 inches and 3 inches, I can do one side squared. So it would be 3 to the second power, 3 squared. So 3 times 3 would be 9. So I have to do 72, take away 9. 72 minus 9 would be 63. 63 inches squared is the total area of only the part that is shaded in. All right, boys and girls, this is your extra practice. It's taken from Go Math Practice Workbook. Go for it. Try your best. Pause it here. Try to solve these problems. And when you're all done, check the answers. And here we are. You can check your work. See if you've done it right. If you did it wrong, go back and see and think, what did I do wrong? Go back through the steps. Problem number 2 and problem number 3, you can follow the steps that I initially gave about using a chart, identifying the shapes, finding the formula for each shape, and solving. For 4 and 5, don't forget to find out the entire area of the entire space and then subtract the space that is not shaded, but you have to find out the correct formula to find the area of that shape and identify the shape before you subtract it. Okay, because here you notice you have a triangle, you're going to have to remove the area of that triangle, and here you have a rectangle, which they have different formulas to find the area for each, okay? All right, good luck, boys and girls. Please subscribe to my YouTube channel. This is Mrs. Roman. Any questions, feel free to write them in the comment space, and you can also DM me on Instagram, Educating with Love. Also, of course, you can contact your personal teacher directly. We're all here to help you.